I think in some weird way, we haven't been honest. And the only thing that's been allowing us to be so dishonest about biology has been, in some sense, the cost, the lack of power, and our clumsiness.
So last November, it was announced at the World Summit on Human Genome Editing by a Chinese biophysicist named He Jiankui, announced that the prior month, in October 2018, the world's first gene-edited babies had been born in China, two little girls. And he was first in China. The government and the People's Daily said, this is incredible. It shows Chinese scientific triumph. And then there was this international condemnation, myself included. And then they said, all right, then there was a buckling down. And there's been a huge debate. My World Health Organization committee was created in the aftermath of that, because people would have always said this is coming. And actually, my book was already in production then, and I'd already said we're going to see the world's first gene-edited babies. It's going to happen in China. And then I called the publisher, hey, we have to pull out of production. I just need to add 3 little sentences saying this thing that I had predicted has already happened. But even I would have said it wasn't going to happen in 2018. I would have guessed 2022. So that already happened. And it was very controversial for a number of reasons. One, because he was incredibly sloppy. He didn't get approval from the hospital in which he was operating. The consent of the parents was totally uninformed and misinformed. But on top of that, the target mutation was a gene called CCR5. It wasn't, so in these kids, their father had HIV and their mother didn't. And so forgetting genetics, in a case in China or here, if a father has HIV and the mother doesn't, there are plenty of ways for them to have a child who's not going to have HIV. But what He Jiankui did was try to edit the CCR5 gene in a way that is similar to what a number of Northern Europeans have, where they have 2 disrupted copies, which gives them increased resistance to HIV. Maybe more susceptibility to West Nile virus, but increased resistance to HIV. And that's what he was trying to do. He wasn't trying to fix an existing problem. He was trying to create, in many ways, an enhancement. And then a few months later, a report came out that mice who had this same CCR5 mutation were doing better in mazes than mice without it. So then there were all of these stories coming back to storytelling, like, wow, maybe these kids are engineered to be smarter. And then there were scientists a few months later who did an analysis based on the UK Biobank, which is probably the world's most useful genetic database. And they found a correlation between this disrupted CCR5 and lifespan. People were living shorter lives. So it was premature, and certainly I've publicly called He Jiankui a villain, which I think he is. But this is a harbinger of where we're going. The age of human genetic engineering has begun. We have 2 gene-edited babies that we know of. The 3rd Chinese baby has probably already been born. There's a Russian scientist, Denis Rebrikov, who's announced that he has 5 parents lined up, and it's going to go 1, 2, 5, and within a decade, we will have thousands of genetically engineered babies.
So I was going to ask you, remember I was going to ask you for a positive story, a negative story, and a story about stagnation.
Sure.
In some sense, maybe you've just given me a negative story, which is that somebody starts editing children in a way that they're looking for one trait that's positive, but they don't understand that something is mediating a trade-off.
And evolution is a trade-off, and that's why it's so complicated.
Right. I mean, there is the issue that you could be, to borrow from finance, at an interior point, so not on an efficient frontier, and you might be able to take 2 things that are involved in a trade-off and optimized both of them because you weren't already at the point where the trade-off starts to bind.
It's true, but in finance, everyone in finance, and I live in New York, is saying, well, we understand some of the variables, we don't understand all of the variables. And the same is true in genetics, that in the old days, people used to say, there's a gene for that, the tall gene, the short gene, the smart gene. And now there's a polygenic hypothesis, meaning lots of genes. And there's even an omnigenic hypothesis, which is even more complicated. And so to understand those trade-offs, we would need a much greater knowledge of genetics than we now have, which is why For me, when I write about genetic engineering, which I think is a much bigger category than gene editing. And the mechanism of genetic engineering, I think, is primarily going to be first embryo selection, IVF, and embryo selection, which is why I think we're moving toward the end of procreative sex. And then it's going to be using stem cells to create a virtually unlimited number of eggs. It's called in vitro gametogenesis. And so if we do that, and if you're selecting from 15 pre-implanted embryos in traditional IVF and PGD, you don't have that many options because it's just you're starting with 15. But when you're starting with 10,000 or 1 million, then you have real options. And that's why I think everyone's focusing on gene editing and CRISPR. But as I see it, for human genetic engineering, the real story is embryo selection.
Do you want to say what CRISPR is for those who don't know?
So CRISPR is a gene editing tool. I mean, the shorthand that everybody uses, it's like a word processing. So you think of the genome as a string of letters, which is how we understand it. You put your cursor. So putting your cursor, you have a guide RNA that goes to a certain point in the genome, and you use a cutting enzyme. And there's many different cutting enzymes. The most popular is called Cas9, but there are many others. And traditionally, you make a double-stranded cut. And so it's very much like word processing. You cut something, and then you can just leave it deleted, or you can add something. Now this is this incredible age where pretty much every day there's another story, not just about a new application of gene editing, of CRISPR, but new types of gene editing tools. So we're moving very, very rapidly toward a world where we are going to be able to edit all genomes, including our own, increasingly at will. And that's a world where we are able not just to read genetics, that's sequencing, but to write and hack genetics. And that introduces this concept of induced biological variability, which is
biological variability.
Like we're going to be able to screw with nature, and that people recognize that their information technology is variable. That's why you think your new phone is going to be better than your old phone. But we somehow feel like we're kind of that this biology is our biology. I'm a Homo sapien. My parents are Homo sapiens. My kids are Homo sapiens. And so this idea that we can rewrite life, it's counterintuitive, even though intellectually people get that somehow we got from single-cell organism state to this over almost 4 billion years. And so that's this big change. I mean, that's the kind of the core message.
We've been over, I guess this is a little bit confusing to me. I often shock people by telling them to Google glow-in-the-dark rabbits. And these transgenic rabbits that have this GFP, green fluorescent protein, expressed in them that I guess originally came from jellyfish.
Correct.
I think it's the Turks who manufactured a whole bunch of bunnies that you can read by. Now, we could, of course, create transgenic humans that lit up at night, almost certainly. And is this something that we should be kind of more playful with, more excited by,
it's hard. So
how do you think of it?
Yeah. So the basic thing is we've been able to do gene editing for a while, but the new tools are faster, cheaper, and more precise by a long shot. And so we have this ability to make big, big changes. And we were making in the old days, we made genetic changes to crops, not just by selective breeding, but we just would bombard crops with radiation and then just see what happened. There'd be a kind of a gazillion different options. And then you'd say, oh, these grapes don't have seeds. Let's make more of them. And now we're able, in a much more precise and targeted way, to do that. So then your question of playfulness. And in some ways, I mean, science, people think about science as something that's rigid and dry, but there's a lot of creativity. I mean, I mentioned George Church. People like George Church, these are dreamers, and they're dreamers who are saying, well, now we're dreaming. How do we turn these dreams into reality? But when we talk about the future of human life, we need to be really careful. As I said to you before, Eric, my father came to the United States, father and grandparents came to the United States as refugees from Nazism. If you had asked the Nazis what they were doing, they would have said they were implementing Darwinism. That's what that's the essence of Nazism. And we have all of these Nuremberg trials about human experimentation. And so if we are, and I personally think that we will engineer our future children,
right,
and that we must. I mean, we want to survive. Our planet is going away. We can't stay on this planet forever. But we have to do it carefully and thoughtfully and methodically and responsibly. And so it can't just be playing around with life.
Well, but I want to be both the devil's advocate and the angel's advocate.
Yes.
I'm not actually convinced that this sobriety makes sense or is possible. I mean, your point is that this is getting cheaper and more powerful. And what that usually means to me is that it's moving towards a garage, that sooner or later...
Already, there's this DIY bio movement, biohackers,
right,
and it's already happening.
So my point is that once things become cheap and powerful, they can be done quietly, even if they're criminalized, even if we have panels on ethics. I think in some weird way, we haven't been honest. And the only thing that's been allowing us to be so dishonest about biology has been, in some sense, the cost, the lack of power, and our clumsiness. So to get back to this most dangerous question. So you and I both come from Jewish backgrounds, and we were on the losing end of a eugenics experiment writ large gone mad.
Right.
Yet, the problem that I see is that we are uncomfortable with the fact that eugenics doesn't really almost mean anything. In other words, mate selection is a form of genetic selection. And if you decide that dinner and a movie is eugenics, then you've drawn a line at a super early stage.
Oh, you got sex for dinner and a movie? That's a good deal.
Moving right along. On the other hand, if we just decide, hey, it's a free-for-all and you should be able to do anything. But the word eugenics, for example, has worked in some sense because it's not really properly defined. It's not clear where good selection begins and ends and bad selection. I would say, and tell me if I'm wrong, that we've been lying, that there is no way, in fact, of drawing a line, much the way we have in the pro-life, pro-choice, where both of these camps make no sense. I would say that the pro-editing, pro-hacking position and the anti-hacking position make no sense at all, and that we're really left with a permanent struggle. Am I way off?
No, I agree completely that if we say we can never do it, that's the wrong answer. We're going to have to do it, and we're going to want to do it. Who wants to have a kid that's going to die of a terrible genetic disease when we have the technology to change that? Who's going to want to have their parents get dementia if we can prevent that? I mean, I just think it will be nuts for us to say we have these powerful tools that can do unimaginable good, and we're not going to do it because these tools also have a dangerous side effect. And that, like, we wouldn't be in cars, we wouldn't be using plows, we wouldn't use any technology if that was the case.
Well, this is, I mean, in some sense, this is the position of, let's say, the Amish, that, at some level, there's a slippery slope. Yeah. And you're suggesting that we move midway onto it. You've called the Chinese guy who's doing this a villain.
Yes.
We've both talked about the dangers of Nazi Germany, and yet we're both kind of excited about the idea of freeing people from risk of breast cancer or maybe even enhancing cognitive capacity.
For sure.
Maybe I don't even have a point or
position. I'm just
hypocrite.
agreeing with you. I mean, people use this slippery slope like it's a bad thing. Like, first we started with, curing this disease and then we cured that disease. Like, some slippery slopes are great slippery slopes. You talked about your dinner in the movie. That was a slippery slope toward love and marriage and great for us. So certainly the people who say never do it are wrong. And the people who say just no restraints, no holes barred, let's just let 100 flowers bloom, that also is wrong. And so what we need to do is to find some place in the middle, which brings me to your point about eugenics. And again, with my background, it's very sensitive to talk about this, but right now the term eugenics is used as a cudgel. Like somebody's doing, say, oh, that's eugenics. And people say, oh, I'm not in for eugenics. And in some ways that's appropriate because there's so many horrible things were done in the name of eugenics that maybe they've just ruined that word. So let's just imagine some other word to describe this selection. And again, even using the word selection, and I write about this in the book, you say selection, you think, oh, Mengele. Mengele is selection of who's going to live and who's going to die. But I talked about these 10 embryos in a dish, in a lab, and you're going to have to pick one. And what are the criteria that you're going to use to determine which of those embryos get implanted? And if we say, well, I want one that have a child that's not going to die of a terrible genetic disease, that's a normative choice that it's not just in some abstract, objective world. It's set within the context of us because you can just move one little step closer. I talked about Down syndrome. I do a lot of speaking, and the parents of Down babies and others are saying, like, wait a second, are you making a normative statement saying that a child with Down syndrome has less of a right to exist than someone who doesn't? I always say, no, that's not what I'm saying. But I am saying that if it's a choice, and we already know the answer to this because of the abortion, if it's a choice, people aren't going to select to implant, in most cases, babies that have Down syndrome.
Right. I guess this goes back to a very dangerous conversation that I had with Jim Watson. Now, you and I have both encountered Jim Watson, and I find that he somehow went down a bad path where he got so tired of being told what he could say and what he couldn't say that he decided that he would start saying the most offensive things possible. And, I'm on record as saying that the legacy of Jim Watson is way too important to be left to Jim Watson.
I agree.
Now, with that said, what I learned in part was that when Jim and his friends between 53, when the double helix structure was elucidated, and I guess 63 when the genetic code was figured out by somebody else, Marshall Nirenberg, that group was shocked that we pretended to care about our identity in the form of these letters, this computer code in our cells, if you will, but we never really accepted what they found. And as a result, whenever they started to talk to us about identity or different characteristics, they found that we were so attached to our pre-genetic understanding of ourselves that we actually won't give it up. And we will fight anyone tooth and nail who tries to tell us, this is really a consequence of information technology as developed by natural and sexual selection. Are we stuck in a culture where we can't actually update to realize what we figured out 70 years ago?
It's so hard for people because in some ways our ability to look under the hood of what it means to be a human being is challenging some of our most ancient mythologies, our understanding of who and what we are. And so we love to have this idea of, I can be anything that I want if I put my heart to it. And it's this mystery of life is unfolding. And even things like parenting is really important that some people are now challenging. And it's really, really difficult. I mean, it's just to give a very narrow example. I talk about this a lot to say, like, I'm a runner, and I run marathons. And there is nothing that I could do to be, pretty much nothing, to be a world champion, like the top world champion marathoner. Because when you look at the fastest marathon times in history, a freakishly disproportionate number are people from this same valley in Kenya and Ethiopia. And then one tribe, the Kalenjins in Kenya, about 4 million people. And then one sub-tribe, the Nandi sub-tribe, 1 million people. It's genetics. And yes, it's great for people to try really hard, and we all have a genetic range of possibility, and we should aspire to be at the top end, whatever that means in a given context of our potential. But if I don't have the genetics to be the world's fastest marathoner or sprinter or abstract mathematician, I'm not going to get there? And that's really hard because we tell ourselves different stories.
Well, so let's focus on this as a practice, as a warm-up, and watch where it goes. So my belief is that between 1897, where we started keeping records of the Boston Marathon, and 1987, there were no winners of the Boston Marathon. I think not one from either Kenya or Ethiopia. After 1987, it is not exactly total domination.
Yep.
I think there's a Japanese, there's a Korean, maybe there's an Italian, I've forgotten, but it is almost 100% with a few exceptions, and it may happen in years where the weather is a little bit different, that it's won by this very small group of people in Kenya and Ethiopia. How do we go from a point where this was a very diverse, and it was up for grabs, it was really athleticism in some sense, to a point where it just is genetics and we found the special people who are wildly well adapted?
Because the world wasn't connected enough, and so people in Kenya and Ethiopia weren't competing, and there wasn't prize money, and all these infrastructure things that have brought us together didn't exist.
But and so would you say that would have a negative effect on the sport, that now we don't even feel motivated to enter, or we just want to watch?
People ask that question a lot, in the sense, well, what happens if we have genetically optimized people fulfilling certain roles in sports? Are we going to care because there's going to this kind of unknown mystery? But that's what's already happening. It's just that we didn't know. I mean, if we just were to go back and sequence, people who've been our greatest athletes, especially in the sports where you can really isolate specific functions, and
like swimming,
swimming, you have to have access to a pool, you have to have great coaching. But I think like running the 100 meters, it's just kind of this standard human thing. All kids run, and we're going to find out that people are genetically optimized for certain functions, and we can't lie to ourselves about that. And yes, there's this fear, and nobody wants to live in kind of this Plato's Republic society, right. But you also don't want to live in a society where the people who are doing mission critical functions aren't the people best suited to do those things. I mean, there's like the joke about the German chef and the Italian policeman. If you kind of have the wrong person for the wrong job, that could also hurt a society.
Well, I have to admit that I don't have the same clarity that you do. So, for example, if I go to the next example, so I believe that it has to do in part with the ability to radiate heat in terms of marathon running, that's really the limiting factor. What happens when you look at something freakish like the number of female chess players in the top 100 chess players
in the world,
and you find that it's 1 in 100 is female, and you've got a single protein, SRY, that determines whether or not some sort of template proto-human being goes male or goes female. Are you prepared to say that we should just accept if we find out that there's a genetic component for spatial reasoning, for example, or that there are, I believe, 3 grandmasters of African origin? I'm not comfortable with that conclusion. It may be that conclusion somehow comes out of the genetics, the way your Boston Marathon example comes out of the genetics. But I don't know what kind of a society I would be living in if I were comfortable saying, wow, there are really huge disparities. And I'll give you the most dangerous one for you and me. Ashkenazi Jews represent 0.25% of the world's population, about 25% of the physics Nobel Prizes. Yeah. I was shocked when I spit into a tube for 23andMe that it knew my religion. Now, I hadn't thought about the idea that Judaism is, among many other things, a breeding protocol.
Yeah. Of having the smartest people, like the rabbis for hundreds of years, have as many kids as possible versus the Catholic
priests. That's one story.
Yeah.
That's one story. Another story would be that previously unimportant skills like mathematical ability for money lending might have been fetishized by a group that was allowed to do that and little else. And lo and behold, that turned out to be very important in a world dominated by a computer program. I'm not sure which story we're telling. I'm not sure what's true, but I'm trying to get at a different point. If I accept the idea that this particular valley subtribe in Kenya and Ethiopia actually has a genetic advantage at marathon running, I'm not terribly disturbed. And as soon as I kick that over into things like chess and physics, it doesn't feel very good to even be thinking about these things.
This is really uncomfortable stuff.
Yeah.
And it exists in the realm of our most taboo, difficult topics. So let me take your three examples: the women chess players, the Africans, and the Jews. So for women chess players, it is just a fact that when you just look at the top grandmasters in the world, it is almost entirely men. That is not because there aren't enough women who are playing chess. That is because of the brain structure that allows a person to be great at chess. The male brain, on average, and certainly at the level of these grandmasters, is better suited for that. There could be another game that could be just like chess with a different rule set where the structure of women's brains could be better suited. And I would not be at all surprised if in whatever game that was, that all of the grandmasters were women. And I just, so many people have looked at this.
Yeah, but what if such a game doesn't helpfully materialize? In other words, what you said, which is, again, I'm not blaming you, and I'm struggling with this issue. I don't know whether I want these things investigated, not investigated. I don't know whether I want to tell a sort of a soft story around something that I suspect is true. I mean, you can't actually back out exactly that this is brain structure, because it could easily be that in order to be at the very top of the chess pile, you have to be completely obsessive about chess. And it may be that it's an obsessional trait rather than an ability trait that discriminates against females. Or it could be, for example, that Africans dominate speed chess, which would be a different variant of another game. In all of these circumstances, my claim is there is no good place to stand. And this is the thing that I don't know how to communicate to the world, which is we now have so much information and we have so many social needs that the information we have and the social needs that we have are at least at risk temporarily of clashing in a profound and destructive way before we figure this out. Would you agree?
100% agree.